Wait, when do you...
For this experiment, we are going to measure velocity. Jonathan will kick the ball from the penalty spot, which is 11 meters from the touchline. Marco will time the ball, and then we will divide the distance by the time it takes for the ball to travel that distance. Go. In this experiment, we are going to look at displacement. Displacement is defined as the change in an object's position. Right there, Marco and Derks just passed the ball back and forth to each other. The displacement of the ball in this scenario is 0 because the ball returned to its starting position. In this scenario, Derks received the pass and did not return it. The ball's displacement is the distance in between Marco and Derks because the ball did not return to its starting position.
We will be finding the acceleration from free fall. Derks is 1.75 meters tall. Johnny Campbell will be dropping the ball from that height at rest. We will be using the formula x equals VIT plus half AT squared. James will be timing it. Alright, 1, 2, 3, go. What was the time?
0.52 seconds.
You heard it from him first.
In this experiment, we will be talking about Newton's first law, the law of inertia. This law states that an object at rest will remain at rest, and that an object in motion will remain in motion unless acted upon by an outside force. Here we see Marco attempting to kick the ball, but he misses and the ball does not move from its starting position. Now Marco kicked the ball. Here you see that the ball moves forward. The ball does slow down, however, because the friction between the ball and the ground is the outside force that is acting upon the ball. If the friction were not present, the ball would continue to move until acted upon by another force. In this experiment, we will be discussing momentum. Momentum is described as the product of the mass and velocity of an object. We know that the mass of the ball is 0.23 kilograms. We will be measuring the velocity of the ball and then using the formula momentum equals mv to determine the momentum of the ball at that velocity.
Alright, wait,
Marco will be timing it using his phone.
Alright, so, wait. Okay. 1.76. So, that was 11 meters. 11 divided by 1.76. 6.25. Yo.
And there you have it.
In this experiment, we're going to talk about potential energy. That is the energy associated with an object because of the position, shape, or condition of that object. The equation for this is PE is equal to mgy. The height of Derks is 1.75 meters, the mass of the ball is 0.23 kilograms, and the gravity is 9.81. James is holding the ball at the height of Derks' head, and using that information we can determine the potential energy of the ball at this time. For this experiment, we're going to talk about kinetic energy. Kinetic energy is the energy of an object that is due to the object's motion. The equation for kinetic energy is 1/2 mv squared. We will determine the velocity of the ball by dividing the distance, which is 11 meters, by the time it takes the ball to travel that distance. Using the previous equation, we will successfully determine the kinetic energy. In this experiment, we're going to talk about conservation of mechanical energy. Mechanical energy is the sum of the potential and kinetic energies in a system at any point in time is constant or conserved from beginning to end when friction is neglected. Potential energy is present when the ball has a height, while kinetic energy is present when the ball is moving. Derks will punt the ball. When the ball is at its max height, only potential energy is present. When the ball is just about to hit the ground, only kinetic energy is present. Not counting friction, the mechanical energy will always remain the same whether it's potential, kinetic, or both.